So hello everyone. So this is our first video of our C Programming Bootcamp. So before I start, let me tell you all the things that we are going to cover today. The first thing is that we are going to know about the introduction to the programming, computer programming, and then we are going to see about the programming languages that are present, and then we are going to see about introduction to the C language, and then we are going to see operators in C language. So before we start, let me tell you about the attendance form that will be posted in the live chat at the end of the session. And don't forget to fill the form for attendance. So let me start. What is computer programming? So computer programming is a process of designing and building an executable computer program to accomplish a specific computing result or to perform a specific task. So as the statement is very clear, we want to the process of designing and building an executable code, right? So to accomplish a specific computing result or to perform specific tasks. For example, a very small program that I'm going to tell you is a calculator. A calculator runs on a particular program, nothing which performs nothing but operations. So the task over there is calculations, and the design means the calculator should contain numbers, right? So it should also have a design so that it also has the numbers and executable. So whenever you press equal to or press enter, it should give us a result. So building an executable code, whenever you press enter, it should give us a result. So we should create an executable code for designing and to perform specific task of giving us an answer. So you can say calculator is a behind the calculator there is computer program which runs over there. So to easily understand, you can just remember about the calculator, as that is a very easy thing, and then we can relate to this. A computer programming. See, we need to process the design and build an executable computer program to accomplish a specific computing result or to perform specific task. Right? So what is an operating system? So we know about the operating system. So we say about the operating systems. The easiest as soon as we say the operating systems, you will remember the Windows operating system, right? That is an example of operating system, and there are Linux operating system. There is Mac operating system. Now let us understand what is an operating system. An operating system is a group of computer programs and another software that lets people to interact with the computer. Right. So as you know, very well know, the operating system is each operating system is different from other. We need to handle it differently. The features are different. So that is about the operating system. It manages computer hardware and the software resources. So it provides common services for computer programs. Right. So about the C programming language. So the C programming language is a computer programming language that was developed to do the system programming for the operating system Unix, and it is an imperative programming language. So let me tell you about the block diagram of the computer before I explain the previous slide. So in the block diagram of the computer, so for example, now again let us take the example of a calculator. So in a calculator, what does it do? Now, if you want to add two numbers and let the two numbers be 3 and 2, okay, you want to add two numbers 2 and 3. So you will give the input as 2, and you need to do the operation plus and then the number 3, and you want the answer for it. So how does it work, right? So we'll give the input and we know it will give us the output. So what happens? So this is nothing but the block diagram of the computer. If you are writing for any exams, this might be asked. So we know about the central processing unit. It is a rectangular cuboidal box that is present adjacent to our personal computers, and which is also present in our laptops and almost everything. So you know about the central processing unit, and the central processing unit can be based on two things. So control unit and the arithmetic logical unit, and arithmetic or logic unit. And the arithmetic logical unit is also known as ALU, that you might have studied in your lower classes, and the control unit. So whenever we want to you want to add two numbers, right? So 2 and 3. So we want to add 2 and 3, which will be stored in the memory unit. And with the memory unit, the arithmetical and logical unit will act on the operations, will do the operation 2 plus 3 equal to 5. That will be given to the central, this thing. And the whole box is central processing unit, right? So from arithmetical logical unit, it will give again to the memory unit. See, there are two arrows in the same way. The control unit is also over here. So from the control unit, it will come to the memory unit. And now again, that memory unit will store that 5, sum of 2 and 3 in this memory unit. And again, it gives us the output. So this is how a particular operation or a particular calculation or a particular computation, in fact, will be done. That will give us the output. So coming to the programming languages, right? So there are three. You can divide the whole programming languages into three types. So the low level language, middle level language, and the high level language. So before I get to about these things, let me tell you about the history of how it started. In early 1872, Charles Babbage has made something known as a computer. Okay. He actually wanted to make a machine which stores data and which is accessible to the data, which gives us accurate values on doing particular calculations and to perform tasks. Okay. So what they did was, instead of they made a key. Okay. That key is nothing but ASCII, or ASCII, and we call it as it is a short form for American Standard Code for International Information Exchange. I'm sorry, for information exchange. So for it consists of the letters and the numbers. I mean, it consists of all the letters, alphabets, and each alphabet, if it's a capital, it's given a number. If it's a small, it's given a number. And according to that particular number, it is changed into binary. Okay. A number can be converted into binary. Binary is nothing but it consists of two digits. Okay. So the binary digits are zeros and ones. So the whole alphabets which are converted into ASCII values, that ASCII value is again converted into number. Okay, numbers can be converted into binary numbers. Okay, and the operators like plus, minus, into, and division, means addition, subtraction, multiplication, and division. So again, that can be converted into binary digits. That has been converted into binary digits. And for example, as I said before, we want to add two numbers and let it be 2 and 3. Right. So to add 2 and 3, they used to convert the number of 2 into binary digit plus the operand into binary. Something like that. Okay. The operand into binary and again 3 into binary. So they used to write ones and zeros there. They used to type ones and zeros, and to give the result, again they used to get it in binary. Again, they need to convert it. So that is about the machine level language. It's the first level language that has ever started in the 1870s itself. In the first computer, they have used the machine level because the machine can understand ones and zeros. Because the machine can understand ones and zeros, we are converting our calculation, whatever operation that we do in the machine level language, that is ones and zeros, it is known as machine language. Okay. But the problem is every operation that we need to do has to be typed, right? So for one particular digit, we need to type 2 digit. For example, for 2 also, for the number 2, if you want to write it in the binary language, it is 1 0. If it is like that, for everything we need to type zeros and ones, which is a time taking work, and it is a lot of work. So they wanted to they wanted to make it better. And the next language they thought, and the next type of language that they thought is assembly level language. Now, what is the assembly level language? So here, for in the machine level language, they they have they have to write ones and zeros. So here in the assembly level language, for the operation, operand, and everything, they in the machine level language it is ones and zeros. In the assembly level language, it will be done by mnemonics. Mnemonics is nothing but short forms. So, for example, you want to add two numbers. Again, adding two numbers, 2 and 3. So, adding 2, let it be A is 2 and B is 3. So, they used to write it like load A equal to 3, load B equal to 2, and they used to write add and load add A and B, and it should add the result and save the result in A. So again, load A with the result and the answer they used to get. Again, this is also time-taking process. We need to write the short forms, right? So instead of this again, assembly level language, they wanted to make a better language. Okay. So that is nothing but we should understand in a more easier way. And the computer should also understand in a easier way. Okay. So they started having a high level language. Okay, see here, that is nothing but a middle level language, C language, and a higher level language. Okay, so in a higher level language, here in the machine level language and the assembly level language, the more it is comfortable for the computer, and it is very less comfortable for the human to give the input, right? To give the input to write the program, everything was hard and it is time taking process. So instead, they want to make it more easier, and in the 1970s itself. They have started something known as this higher level languages, C programming language. C programming language is a middle level language, and some say it is a high level language. Okay, so it is neither very comfortable for the human, very comfortable to the computer, right? So many say it is a middle level language. So it is consists of COBOL, Fortran, Pascal, C, C hash, Prolog, Java, and .NET, and etc. Okay, so what is a compiler? Now, okay, now I am there. Now, any language. So as you know, if there is a file, now if there is a file and the computer needs to store data, any file will be converted again into ones and zeros. That is nothing but the binary digits. Okay. So to store a particular letter, to store a particular word or numbers, whatever it is, it will be converted into ones and zeros. Okay. So still the computer or still our phones and any data device which stores data, any machine which stores data will convert our data into ones and zeros. Okay, that hasn't been changed yet. So whatever we write should be understood by the computer, and then it should store the data. So before I get into that part, so if we write a C, if let us assume we are writing a C program, so that program should be executed, right? So to execute that program will be converted into ones and zeros, and then it will be executed. Then that will be run, Okay, that will run. Right? So a compiler is a program that translates a source program, the program that we write in C, written in some programming language. For example, we are taking here C into machine code. Machine code is ones and zeros for computer architecture, set of rules and methods. Right. So what is an interpreter? So an interpreter is a computer program that directly executes the instructions written in a programming or scripting language without requiring them previously to have been compiled into a machine language program. See what does an interpreter do? Without compiling into a machine language program, right? Without using without being compiled only, we were able to interpret it. So that is nothing but an interpreter. So this is the difference between a compiler and an interpreter. And there are some differences present here. See, into a, okay, in the compiler, it converts the whole machine code as a whole. Okay, once the program gets executed, then we compile it. Okay, it will be all will be done, all lines will be done at the same time. If it is in an interpreter, it converts the machine code one statement at a time. Okay, after one statement, the after one statement after one statement get interpreted, then the second statement will be get interpreted. This has one whole thing, and this has one after the other. That is the difference. And here it creates an object code file. As I said to you, there will be a .exe file that will be created. Okay, I'm going to show you when I'm going to write a hello world program. Whenever we write that program, first that will be created, and again that will be run in a compiler. And an interpreter does not need to create an object code file. Why? Because it is not being because it is compiled into directly. See, without requiring them previously to have been compiled into a machine level language program. Without being compiled only, we are going to execute. I mean, we are going to interpret it. So we don't need to create an object code file. That is fine. Now, program execution is relatively fast in compiler program, and the object code file is produced. Now again, this object code file is executed. That I've said you, the .exe file will be executed. No need of free compilation unless we need to change the source code, right? So in an interpreter, as it needs to do line by line, it is relatively slow. And every time we want to run a program, we need, again it needs, see here in the compiler, once the .exe file is produced, we don't need to compile it again. But in an interpreter, as it doesn't produce any object code file, every time we want to interpret it, right? Every time we want to interpret it, it needs to read one line after the other, and then it executes. So it's slow, right? So these differences might also be asked in the examinations. So, what is C language? C language is a general purpose computer language. General purpose computer programming language. C is also said to structures programming language or function oriented programming language. Right. And C is a high level programming language as it is comfortable for us to write it. Right. So why do we use C? C language is used to create applications or software. Okay, so initially C was used to create an operating system called Unix, or Linux programming language. Linux operating system also uses C language, right? So this before Windows, we used to have before Windows there were many operating systems, and some of them was Linux, Linux, or Unix. Okay, and Ubuntu. These were all the operating systems, and the programming language used to. At that point of time, we didn't have mouse at all. So instead of mouse, everything that we need to perform, every operation that we need to perform, we need to type it, and that typing would be done in the C programming, right? So C program is very important, right? C is very important at that point of time. So the whole operating system used to run, and it is still running. It is not. It hasn't been stopped, and the whole thing needs to be. I mean, the whole operations need to be performed on C in C language. So the popular software like Linux operating system, PHP, hypertext. Hypertext pre-up and MySQL are created using C language itself. Right. So MySQL is for databases and operating the structured query language to maintain databases. Okay. So generally, C language is used to create the following: operating systems, language compilers, assemblers, interpreters, text editors, networks drivers, and databases. So you know about the operating system that I've said you right now. The language compilers. See, the language compilers I've said you only about the C language. Now there is Python language. Now there is a Java language. Now there is Ruby. There are many programming languages. So to make that compilers, once we want to run the code and everything, that code, everything that will be done in C language, the assemblers. So coming to the assemblers, I'm going to say it to you later. See, assembler is nothing but it is a it will translate our code into machine level language. Okay, so that is about machine level language. Interpreters, I said you. Text editors. Text editor is a very small thing. As you know, you can open Notepad in your Windows operating system and you can write code over there. You can write HTML, you can write Java, you can write C over there. So that is nothing but a text editor, networks, drivers, and databases. So databases like, for example, if you want to write structured query language, so structured query language, you need to have databases. So that database that has been developed by C language. Okay. So history of C language. Okay. So the C language was developed by Dennis Rich in the year 1972. So the first computer was started in 1872 itself. It nearly took 100 years for a better language to be used. Okay. So why did we name C is a question that many people ask. Okay. So why did we name C? First, there was a language which was developed by Bell Labs and they named that language as B language as the first letter of the lab name. So once it was famous, they want to improve it, right? So they wanted to improve the features and they named it C, the third letter of the English language and the next letter of the letter B. So that is nothing but the C language. So it was this person, Dennis Rich was the main person. Yeah. And he was born on September 9th, 1941. He was a computer scientist, father of C and the Unix operating system. C has become very popular for various reasons. One of the very early programming languages, right? Still the best programming language to learn quickly. C is reliable, simple, and easy to use. C language is a structured language. Modern programming concepts are based on C. Okay, so once you learn C, all the programming languages that you want to learn, it might be Java, it might be Python, it might be Ruby, it might be R, it might be anything, right? So once you have learned C, you can relate and easily understand other programming languages, right? So basics of C programming. So coming to the basics of the C programming, C is a structured programming language. So every instruction in C program must follow the predefined syntax. So coming to syntax and okay, so for any language, as you know, it might be English, it might be Telugu, or it might be Hindi, Punjabi, Bengali, whatever it is. So it has grammar and meaning. So grammar of a language in programming languages, we call it nothing but syntax, and the whatever we speak has meaning to it, right? So that meaning is nothing but semantics. Okay. So here it might be it should follow the predefined structure that is nothing but syntax. Okay. C is also known as a function oriented programming language. So every executable statement must written inside a function. Okay, it should be written inside a function. Now function is, I'm going to say you in the next tomorrow about the function. Okay, inside a function, and we are also going to see it in Hello World program that we are going to write today. So general structure of a C program. Documentation. It is used to provide the brief information of the program. Now, this part is written using comments. Okay, comments is nothing but if you don't want to, if you have written something in a compiler, for example, and that part shouldn't be included in the program, then we write it in comments. Okay, so we write the documentation part of the C programming language using the comments. Okay, and generally the documentation part does not get executed by the compiler, and it is optional part. but it is a traditional way, and many of them still use it, and it is a recommended part. Okay, it's an optional part, but it is recommended so that you can easily understand what does a program do. Okay, so general structure of C. So the documentation, the pre-processing statements. So the pre-processing statements are nothing but the header files, we call it, header files, and the global declarations, main method, and use defines methods and implementation part. Right. I'm going to tell you, now I'm going to show you how to write the first program in C language. Right. So there are many compilers that we can write C language. So I'm going to show you about the Dev C++. Dev C++. So go to Google and write install Dev C++. Install Dev C++. And you can use this. You can use the bloodshed.net. Right. So you can click on this, download original Dev C++. So you can click on this and click here. So this Dev C++ will be installed. Okay. Okay. ఈ పార్ట్ మొత్తం తీసే. To write the first program, to write the first level program, we don't want to write it in Notepad. So instead, we are going to use Dev C++. So to install Dev C++, here's what we are going to do. So in Google, we are going to write install Dev C++. So this is fine. You can go to any website. Just click on download. So it will start downloading. Yes. So it is downloading, and you can I mean, once you run this file, run as an administrator, you can download it in just 2 or 3 steps. There's nothing you need to do. So in my system, the Dev C++ has been installed already. So I'm going to open the Dev C++. So this is how you're going to, whenever you're going to open Dev C++, this is how you're going to open it. You can also use, okay, you can also use code blocks, right? You can also install code blocks, which is very much similar to the C++. You can also use Visual Studio Code. Visual Studio is a integrated development environment. It is an IDE, right? So it will be more easier. There will be auto completions, but I'm going to go with C++ for now, right? So once you open this, you need to press on this file. So this particular thing, this particular box over here, and press on source file. Right. So when you open and install everything, this is how the Dev C++ looks. So when you want to start a new file, you are going to press here. So we are going to press here and on this particular box, and when you press on this particular box, you're going to press source file. So this is how it looks. So when we want to start a new program, as I shown you in the PPT, we are going to start it with the documentation part, which is the recommended part. This shows what the program is about. So here we are going to write our first level program, right? So I'm going to write it as our first program. That is, okay, let me write it as hello world. So what you need to know is here, okay, the size of the font is very much low. So I'm going to go to tools, editor options, and then in the font, you can increase the size because it is easier to see. Let me write it as 18. That is very much comfortable to us. Okay. So hello world program. And then this is about the documentation part. Once we completed the documentation part, see now this is a multi-line comment. We can multi-line comment is nothing but we can write our comment in more than one line, and until it gets this particular means. For example, if I write something here, it will still be in the comment part itself. It will still be in the comment part itself until we close it using this particular thing. It will be in the comment itself. And there is also a single line comment. Single line comment will be shown like this, right? Double slashes. Okay, double slashes, that is nothing but a single line comment. Now, okay, let me delete this everything. So yeah, let me write our let me start our first program. Hash include stdhottext. This part is of the header files, or is also known as pre-processing statements. So instead of remembering all these that I've already shown you this in this part in the PPT itself. This is the second part, pre-processing statements or header files. Okay, what do these mean? This part is the syntax part of the C programming file. So the std.h is nothing but standard input and output. So again, I'm using, okay, see this part from here is a comment. This part will not be executed by, it will not be seen by the compiler itself. So whatever we write after that, whatever we here also, whatever we write after this part and it ends at this part, it is not going to be considered at all. So we can write how many lines we want comments, and we can give for each and every line we can give the description in the comments. It is very much useful, and many of the coders use this particular part so that even if they even after they leave the job, when a new person gets the job, they can understand the code easily with comments. So many use this comment section, and it is very useful to us, right? So this is about the hash include std.h is nothing but standard input and output. So that is about standard input and output. And .h, okay, again .h is the library. So the compiler needs to know that it needs to take the files that whatever we are writing. For example, here we are going to write printf statement. Okay, so whatever we write in the printf statement gets executed, gets printed in the output file. So in the output file, it needs to be understood that particular part, the printf statement, printf command is being present somewhere. So that particular part is being is present in the .h file. That is nothing but a library, we call it. So that is about the syntax. We cannot change it at all. And coming to the next part, it is a main block, right? So main. So this is about the advantage of a compiler. See, whenever I'm going to write the first the first braces, the second braces will be automatically generated. So please try it. You will get used to it and you'll be very comfortable. And I'm going to write the open brace, the braces here, the curly braces here. So this when we write like this means it is the main block. Int is nothing but integer, right? It is easy to remember. It is just the first few letters of the word integer. And why do we write integer is that if the main block should return some integer, then we are going to write int there. So int is for integer we are going to write it as int, and as it's a main block we are going to write it as main. Now I'm going to print printf hello world. Now there are no global declarations over here, so I'm just no global declarations as I've shown you in this PPT. So again, when you're going to write printf statement, we are going to use double quotes to print particular statements itself. So here I'm going to write hello world. I'm going to print hello world, and that's it. And whenever you the statements at the end should be present at the semicolon, and then return 0. As I've said you, every see the main block should, as I said you before, every main block is in a class, or we can call it as a function, and in some cases it is also called a method. It always contains, it is inside a method, right? And in the method, every statement should be concluded with a semicolon. Now we need to first save the program to compile the program. Now how does the saving can be done? You can go to file and you can press on save, or what I usually do is I usually press on Control S. That is nothing but that is save. So in this particular directory, I want to save my file. So here I'm going to write it as, the program name should be written here. The file name, that is nothing but hello world, and it is not a C++ file. It is a .c file. You need to change it here and press on save. So it has been saved, and you need to first compile it. To compile it, you can press on F9, or you can press this here. See, if there are any errors, you will get any errors, and if there are any warnings, you will get the warning. See, here you can see errors and warnings, and if there is an error, it cannot be compiled and it should be changed. For example, I'm going to show you a small error. If I don't write a semicolon here and then I save it, I should save it and then compile it. I'm compiling it. See, if it makes no sense if I don't, this whole particular statement is one particular statement. So this, from statement to statement, if there should be a differentiation, that is by the semicolon. So I'm going to press semicolon. I'm going to save it, Control S, and then compiling it. Yes, it has been compiled, no errors, no warnings, and then I'm compiling and running it. See, this is how the .exe file will be shown to us. And see now, yeah, see, hello world is being printed. However, I wrote it in the middle of the double quotes. That will be printed along with the along with the exclamation mark. So this is about the first program, and then we are going to continue with the PPT. And see, here the printf statement prints the statements. Okay, printf statement prints the statements, and the return 0 returns the values. So instead of writing return 0, we can also write void main. When we write void main, it means that it does not need to return anything. The void will also be shown to you in the next PPTs. If we write void, there will be nothing to be returned. And if I write int and I don't write return, then there would be an error. Now I'm going to save it and compile it. See, we will not get any error. No errors and no warnings. And again, I'm going to run it for you. See, hello world. Now again, I'm going to show you, if I'm going to write int, okay, not int, it's int, and I don't write return, I'll get an error. See, I'm going to save it, Control S, compilation, and error 0, warning 0. Usually we get an error. Because this is a compiler. Actually, this shouldn't happen, because this is a wrong. I mean, it is not showing us any error, but the classic traditional part should show us an error. It's fine, but in some cases you might get an error. Okay. So actually, instead of using this C++ code blocks or Visual Studio Code, I've said before, Visual Studio is an integrated development environment, IDE. Now, we can also use online compilers. So to use the online compiler, go to Google and press on C online compiler. The most this will be stored in the cloud itself. It is very useful. See, whenever you press on C online compiler, you can find the online compiler. And I recommend the online GDB compiler, because most of our programs can be run easily. See, this is how it looks. Okay, for our convenience, the hello world program will already be written, and you can press on run to run the program, and see hello world will be printed. It is very useful, and you can also save the program You can also save the program using Google Plus. You can log in with Google Plus, Facebook, or GitHub. It is your choice. You can also use this. If you use this particular thing, it will be stored in the your computer itself. There will be a little difference. If in this part, it will be in the cloud. I mean, it will be stored in the internet itself, and you can access whenever you want. So going back to the PPT. Okay, rules for writing C program. Every C program must contain exact one main method. Without C, I told you that the main method, the execution of the program starts from the main method. So only one main method should be there and 100% main method should be present. Right. And every executable instruction must end with a semicolon. So as I said you, in the at the end of the printer statement, we have written a semicolon. And also at the end of the return zero statement, we have written a semicolon over there. And all the system defined keywords must be used in lowercase. Okay, if you write it in uppercase, again we'll get an error over there. Okay, every open brace must have the respective closing brace. So after int main, I have pressed on an opening brace. And because there is a closing brace that has been automatically provided by the compiler, the C++, it's not a problem. But if you write it in some other compiler, there might not be a closing brace. So you need to close it over there. If there is a no closing brace, you will get an error. The variables must be declared in the declaration section before they are used. Okay. So I'm going to show you a very small program here. So here is a hello world program. Now again, I'm going to press this particular box and I'm going to press on source file. And now here it is. We are going to do operations. So operations. So operations on different data types. So that is about the this thing, and now we are going to write the preprocessor statements or header files. That is nothing but hash include stdh, and again I'm repeating stdh is standard input and output, and .h is the library. And now again I'm going to write, there are no global declarations, so I'm going to write it as int main, and this normal brackets, and then the curly braces. And in this particular curly braces, now whatever you're going to write are global local constants, right? So in the local constant, now I'm going to define a particular value. Okay, now if I want to give a value of 5 to a, right? So this is how we are going to write. 5 is an integer, right? So we are going to write as int a equal to 5. So why are we writing int? Why are we writing int here? We know that a value is an integer, and we want to define the value of a as an integer. See, if we look at this particular PPT, we might have understood that for particular int itself, we want to write a value of 5. We can use signed int, we can also use unsigned int, but using an int is very much easy than using all this. Now, what is the difference between the signed int and unsigned int? You might have a doubt. Now, sign, you know about something known as sign, positive sign, negative sign, means minus 10, minus 15, minus 30, minus 45. So if there is a sign, now if it is a positive sign, we don't need to mention it at all. If it is a negative sign, then we need to mention it. So at that point of time, we are going to mention signed int and unsigned int. See, if it is an unsigned int, it means it is always positive. So it has this particular range. If it is signed int, it has this particular range. You can also try each one of them. So to not waste time, I'm not showing you each one of them. So I've shown you the int value. Now I'm going to show you about the char value. Char is nothing but a character. Now you know very well the CHAR is the first 4 letters of the word character. So that short form has been taken here. So for char, the range of values is minus 128 to 127. Char data type is for storing the alphabets, right? It is for storing the alphabets. So I'm going, okay, so this is about int a equal to 5, and then char. See, if it is a data type, it is being bold. See, it is being bold. Okay, so let me write int capital A. So this is small a and capital A are different in, I mean, when you're doing this. So capital A equal to value equal to G. When you're defining something like this, it should be declared in single quotes and not in double quotes, as we wrote in the hello world program for this printf statement. Okay, we are going to write it in single quotes, and let me write capital letter G, and I'm going to close this, and let me print small a value. Okay, small a value I'm printing, and when I'm printing it, it should be written as this percentage d. Percentage d is nothing but the decimal number. So if we have written int, then we are going to write percentage d, and if we write it as char, we are going to write it as percentage c. See how I'm going to write. It is not print, it's printf. I'm mistaken. So it's printf, and then again I'm going to write it as printf percentage c. In the quotes, in the double quote, we need to write it as percentage d, percentage c, according to the requirement. Right here, I'm going to write the value of capital A should be printed. So after the comma, whatever the constant or the variable that we have written, the name of the variable or the constant that we have written, that value will be printed, and that value will be printed in the place where you have written percentage d. In the place, I mean, here I can write value of a. Okay, value of a. Right, so this percentage d, wherever it is present in that particular place, it will be printed. Right. So again, I'm going to press semicolon here, and then I'm going to return 0. So I've shown you the two data types. I'm printing the two data types. Now, according to the machine, here I have shown you in the PPT, according to the machine, the size in the bits will vary. Right. If usually the int data type is of only 4, and in some cases it is 2, and in some cases it is 8 2. In here it is written as 32. You can also, according to the system, it will be changing. If it is 32-bit system, it is different. If it is 16-bit system, it is different. It is a 64-bit system, it is a different. You can also see the size of the data type also. See, I'm printer. Yeah, okay. I'm going to write size of int, and that should be placed like this. Okay, I forgot a comma here. Right, this is how you can write. You can find the int data type in your particular format. So before we run this program, we need to first save it. The name is operation. So operations. So it is a source. It is a C file. You need to change it to like this and press on save. And once you press on save, you need to compile it first. See, 0 errors and 0 warnings. Right. So warnings are nothing but if it is a error, the compilation should be it means it makes no sense, right? So it should be changed. For example, if you miss a semicolon, as I showed before, or if you miss some, if you have done something else, or there are different kinds of error. There are arithmetic errors like division by 0, etc. Are arithmetic errors. I'm going to say to you about it later. The warnings are nothing but it is just a suggestion, but the compilation of the program, the execution of the program will not be stopped by the warnings. But if it is an error, the execution of the program will be stopped. Now, as there are no warnings and 0 errors, so I'm going to compile and run. So this is how it shows. Let me check. See, the value of a is 5. The size of int. Okay, I missed it. I'm going to write percentage d here. Right. And if I want to print everything in a new line every time, I can write like this in this particular slash with n. And here also I want to write it in this slash and n. Right. In some of the books, they may also write it like this. See, after percentage d, if I want to press enter when I'm writing in a text editor, Then we are going to write it like this also. We can also write it like this. See, I wrote it here and here. So there will be printed enter 2 times. See how it works. Control S. Now I'm going to compile it. And now I'm going to compile and run it. See, value of A is 5 and the value of capital A is G, right? So that G has been printed here. This value of A is 5, so G, and the size of int is 4. In my particular system, the size of int is only 4. In your system, it might be 2, it might be 8, it might be 32 also. So here it is. Now I'm also going to show you about the double. Now the difference between, now in the PPT itself, you can see the double will actually be saved for the decimal values. Now in the integer, integer does not consist of decimals, right? It only consists of integers. Char is for alphabets, and we cannot have words in char, so we use something known as array of characters, that is nothing but a string, that I'm going to show you in the further classes. And then again, for the decimal values, we are going to use the double. Now to write the double, see, minus 1.7 e power of minus 308 to this particular, to 15 digits it can be saved. And if it is in long, the values are same, but it is also integer is having a higher range. Okay, it is a little of higher range. It can be short for that. See, now as I said you here, for if it has a minus, as I said you, if it is a negative, then we are going to use signed. If else, we don't need a sign at all. So again, for that also we can use this unsigned and signed. That is the reason the signed and unsigned is not being present here. So anyway, I'm going to show you about the double, right? So the C++, yes. So I'm going to show you about the double. So for double, let me write C equal to 3.14. That is the value of the pi. I like this number very much. So double C equal to 3.14, and I'm also going to print it here, right? Double. Okay, I'm not going to write it as double. Printf. For double, we are going to use %lu, right? %lu we are going to use, and we are going to use the value of C, right? So we are going to write it as C, and here it is. I'm going to save it, Control S. I'm going to compile it, 0 error, 0 warnings. Now I'm going to run the code. See, there is some error over here. Let me check it again. Size of int has been printed, and after that I want to print in a new line so that it will be easily understood. Compile and run. Okay, the value has been printed here. Right, fine. So I'm sorry, I guess it is LF. Yes, it is LF, it is not LU. I got confused a little bit. So double LF. So C 3.14 value has been 3.14 has been saved. See, the number of digits are 6 digits after the decimal. So double is better. And you can also use float. Float is also for decimals. And you can go on using one after the other. You can go on using the different data types that are available here, and according to the range that is present here. See, this is nearly 3 digits, 6 and 6, and nearly 10 digit or 11 digit it is there. If you give more value, then it will give an error. According to the range, you can use these data types. So this is about the data type. Now, as I said you, from system to system, it will vary. The size in bits has been again repeated here. That's fine, not a problem. Double and long double is also present, that you need to remember. Void, in the void, for the void, now as I said you before, I've shown you before, it can also be used in the function that I'm going to say you on the day 3 of this boot camp. And this is a list of 32 reserved keywords that are present in the language. See, now here you know some of the keywords. You know the double keyword, you know the int keyword. Double keyword data type, int is a data type, long is a data type, and again the signed and unsigned I'm shown you. The float is a data type, and again char is a data type. See, this is the reason the C is a very easy language and you can learn it quickly, right? You can know the size of that I've shown you already. So this is a very easy thing that we are going to learn. Break is in loops, auto is in also for functions, switches for conditional statements, else is for conditional statements, if is for conditional statements, for is for loop, while is for loop. Okay, it continues. There are a lot of things. Okay, so this is the operators in C. So this is about the unary operator. The unary operator means a plus plus and minus minus. That is the unary operator. And these are all the binary operators. The binary operators consist of arithmetic, relational, logical, bitwise, and assignment operators. Today we are going to see only two operators because of time constraint, and I'm not trying to load you with many of the details as it is hard to remember. So arithmetic and assignment I'm going to show you, and the ternary is very much important for your examinations too. Now let me show you about the precedence and the associativity. So when we were young, we might have learned, you must have learned about the word mass concept, or the D mass mini say. So that is nothing but a bracket of division, multiplication, addition, subtraction. So what does it mean? When there is a multiplication present, we first need to act on the division, then we need to perform the multiplication, then the addition, and then the subtraction. So in the same way here also, for which thing we need to give the priority, we need to give priority to that particular operator. Now these are the operators that are present, right? So we do not know to give which to, I mean, to which operator we need to give the priority. So that is the reason. Now how the computer gives a precedence and associativity, this is how. So 10 plus 20 into 30 for this particular example I've shown you in this particular slide. See, the into operator, the multiplication operator has higher precedence. So, right. And this plus is an addition operator which is of lower precedence compared to this. So first, we need to perform the multiplication. So 20 into 30, 600. Now I have made a mistake over here by writing it 60. So then we need to perform the addition that is present here. So 600 plus 10 is 610. So this addition will have as a lower precedence. Plus is of lower precedence and multiplication is of higher precedence. So in the same way, this is the order how the operators need to be operators should be performed, and the operations are done. In fact, we don't do the operations, right? The computer does the operations. Now this is how it will be done. And associativity means, I'm going to say about the associativity here. Now you know about these brackets. Now this brackets, and the dot operator I'm going to show you in the later classes. The unary operators. Now this is I'm going to say about these unary operators, arithmetic operators. Now there are in two rows I've shown you the arithmetic operators. I'm going to show you about the arithmetic operators here itself in the program that I've started writing here. Okay, now let me give you two numbers. Now let the two numbers be. See, when you're performing an operation, both the operands means, for example, here you cannot add the integer and this double. Now, because they are not of the same data type, it will give us an error. So that you need to understand. Once you experiment, you try to do it with that particular thing, you'll get an error because they should belong to the same data type. So that is the error. Now I'm going to print it. Printf. Okay. I'm defining int c, a constant, that is sum of a plus b. So have entered it here. So I want to print value of c. So the value of c is Okay, as it is an integer, I need to write it as C here. And I also need to write it here as percentage D here. And as I want to print it in a new line, I'm going to write it like this. Okay, at the end of the command, I'm going to press semicolon, as you know, and I've saved it and I'm going to compile and run it. Okay, see, with the C name, I've already defined the constant, so C cannot be used. So instead of C, I'm going to use D. See, conflicting types for C. Okay, so I'm going to change it for D. I'm going to save it, compile and run it. Zero errors and zero warnings. Fine, that is fine. So I'm going to see value of C is okay. Again, C value is being printed here. I'm mistaken. I'm sorry. Again, we need to change it to D, and here also I'm going to change it to D. Okay, control S, compile and run. I'm very much sorry. See, the value of D is nothing but A plus B, that is 10. That is fine. You have understood the addition operator. This is how we are going to do the addition operator. Here, we have used the assignment operator. Assignment operator is from right to left. We say it as a assignment operator is right to left because we are assigning the value of 5 to A, so it works from right to left and not from left to right. We are not assigning A to 5. The value of 5 is being given to A. So that is about the assignment operator. Now in the associativity here in this particular slide, you can see all the assignment operators are being done from right to left. Okay, so you know about the comma operator. The comma operator, we have been using it here. See, this is nothing but a comma operator to write something, to write the value of something. We are going to use it. And then again, I've shown you about this arithmetic operator addition. Now this particular arithmetic operation can also be done like, see, I'm going to write minus. I'm going to see 5 minus 5 is 0, so value of D should be 0 here. See, value of D is 0. You can see it. And again, instead of writing this, I'm going to write into. So 5 into 5 is 25. So value of D should be 25. I'm compiling and running. Compile and run it. So value of D is 25. Right. And again, 5 by 5 is 1. So it should return 1 value. So I'm saving it, control S, and compiling and running it now. So the value of D is 1. See, this is a very easy assign arithmetic operators, and I'm going to show you a new operator. A new operator is nothing but a modulo operator that is present in the table. That is also an arithmetic operator. This operator returns the remainder when the first number is divided by the second number. What is that? When A is divided by B, the remainder. Right, so it should actually be 0 when 5 is divided by 5. The quotient is 1 and the remainder is 0. So control S, saving it, compiling it and running, compiling it, 0 errors, 0 warnings, and compiling it and running. See, the value of D is 0, the remainder is 0. So let me write here, for example, 8. Okay, control S, right, compiling it and running it, and compiling and running. See, when 8 is divided by 5, the remainder is 3. So that is how it returns. Right. So thank you guys. That's it for today. Don't forget to fill the form, attendance form that is present in the live chat. Right. And tomorrow we are going to learn about the conditional statements and the loops, the iteration statements tomorrow. Don't miss tomorrow's class, guys. Thank you, everyone.